Hi class, this is Professor Smith. I'm going to be doing a movie on discrete probability distribution word problem. An ordinary fair coin is tossed 3 times. Outcomes are thus triples. Heads for H, tails for T, which we write HTH and TTT, etc. For each outcome, let R be the random variable counting the number of heads in each outcome. For example, if the outcome is THT, then R of THT is equal to 1. Suppose that the random variable X is determined as in terms of R are as follows. So they have X is equal to 2 times R squared minus 6R minus 4. Then the values of X are thus. So again, let's review what they mean when they say the random variable THT is equal to 1. Because there's only one head, that's going to let us know, oh, if there's only one head, dun, 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 that's why we have the number 1. And then when we substitute in 1 here in this expression, 2R squared minus 6R minus 4, then we have the following. We have 2 times 1 squared, and 1 squared is just 1, minus 6 times 1, minus 4. And when we do that computation, we get 2 times 1, and 2 times 1 is 2, minus 6 times 1, which is 6, minus 4. And 2 minus 6 is negative 4, and negative 4 minus 4 is negative 8. And so that's why we have the value negative 8. And so those values are all computed for you, so you really don't have to do this computation. I just wanted to explain where they came from. A random variable, if you recall, is just the, let's click on the definition, is a variable that takes on a particular numerical value based on the outcomes of a random experiment. So the random experiment is tossing a coin 3 times, and the random variable is the number of heads you get. Hence, that's why it's called a random variable, a number associated with a experiment. So 1 is the number associated with the experiment of tossing a coin 3 times and counting the number of heads you get. So in this part here, they're really just asking us to fill in the values. So if we take a look at the random variable for X, we can see that it takes on a negative 8 and then a negative 4. So the two values that the random variable takes on are negative 8 and negative 4. And then to find the probability that the random variable X takes on the value of negative 8, we just count how many negative 8s we have. So we can see that we have negative 8 occurs 1, 2, 3, 4, 5, 6 times out of the 8 possible outcomes. So it would be 6 out of 8. So 6 divided by 8, or we could reduce it to 3/4, but I think Alex will take 6 out of 8. And then if we take a look at the 4, it's going to occur 2 times, and that makes sense because the only 2 outcomes are negative 8 and negative 4. So if the negative 8 occurs 6 times, then the negative 4 would have to occur 2 times because there's only 8 possibilities. So we select 2 out of 8, or we could reduce it. So if we wrote 3/4 and 1/4, or 6/8 and 2/8, Alex will accept the answer. All right, it says your answer is correct. So let's clear all my drawings and do more practice. So again, in this one, the random variable is associated to the outcome of a girl or a boy. And then they also have a random variable X that's given by this computation. So since they give us the values, we don't need to plug in or do any substitution. They already give us the values of X. So the values of X are 2, 4, are 2, negative 4. Looks like there's a negative 2. I think that's it. 2, negative 4, and negative 2. So 2, negative 4, and -2. The 2 occurs one time out of the 8 possibilities. The -4 occurs 1, 2, 3, 4. 1, 2, 3, 4. So 4 out of 8, which would be 1/2. And then the -2 occurs 1, 2, 3, which is 3/8. And we can also see that when we add these up, 3/8 and 1/8 is 4/8, which is 1/2, plus 1/2 is 1. So all those probabilities should sum to 1. Let's check our answer. All right, it's correct. Let's do one more. In this random variable, we have the values of x go from -1, -2, -5. I believe those are it. And we see here they only have 3 boxes. So we'd have the values of -1, and -1 occurs 1, 2, 3 times, so that's 3 out of 8. -2, and it occurs 1, 2, 3, 4 times, 4 out of 8, or 1/2. And then the -5 occurs 1 time. The -5 is the random variable, and the probability is 1/8. And if we add those, 3 plus 4 plus 1, because here I didn't reduce the 4 out of 8, so they all have the same denominator of 8. So 3 plus 4 is 7, plus 1 is 8. 8 out of 8, all the probabilities add up to 1. So I hope this short movie on discrete probability distribution word problems is helpful for you.